Good morning, everyone. Thank you for coming to my talk. For those who are watching a recording, it's 10 a.m. And 10 a.m. is pretty early in bear market. So thank you. My name is Ani. I'm a staff engineer at Brave. Quick show of hands, how many use Brave? OK, pretty much everyone. I work on Web3 initiatives at Brave, and that's most notably a crypto wallet. We call it Brave Wallet, which is part of the browser. And I'm going to share our experience building this product and how we managed to teach a beast like chromium to speak Web3. So for those who do not know about Brave Wallet, just open your browser and there would be a wallet icon in the toolbar. If you click on it, it should show you Brave Wallet if you have set it up. Pretty standard, and it's part of the browser, and we are shipping this in the browser itself. So any device that has Brave browser installed has Brave Wallet. So we are making it available to some 50 or 60 million users of Brave. And it's native. And by that I mean it's not a JavaScript wallet. Like most of crypto funds, fortunately or unfortunately, are locked in extension wallets written in JavaScript. And that's not a good idea for a number of reasons. But before I delve into that, I want to quickly explain you what it means to be a native wallet. This is going to be the most technical slide in the whole presentation, so just bear with me. So I want to explain the browser's architecture. It's a browser that's built on top of the Chromium stack, which means there's a main browser process that does a lot of fancy stuff. And there are renderer processes, which are sandboxed, and they run something called Blink. Blink is a renderer engine that's pretty popular. Most browsers use this engine, maybe apart from Firefox. So Brave Core is kind of sitting in the middle of all this, orchestrating stuff. Brave Wallet is just part of this Brave Core. So it is able to compute stuff, like talk to the RPCs, build your balances, create transactions, and it's able to pass it on to the renderer, which runs Blink. So that's written in C++, and those are C++ objects. What we then do is wrap those objects into a V8 object. V8 is the JavaScript engine in Brave. And we make it available to the client, the front end. So in Brave browser, the wallet that you saw in the previous slide, that was React. And it was accessing JavaScript objects. But behind the scenes, it is actually a C++ object. And if you call any function, that's running C++, not JavaScript. So that's an illusion. Works for us. OK, why are extension wallets problematic? Because they're heavy. If you have a JavaScript-based extension wallet, you're probably running tons and like hundreds of these NPM packages, bloating your entire software. So you don't know if they have security issues. And, well, you also inherit not just security issues, but also design flaws, architectural constraints, and so on. So they're heavy. And we also have a diversity problem. So there is a diversity problem in Ethereum, which is that some 83% of Ethereum nodes run Geth. Actually, I think the slide is outdated because it says 8% Open Ethereum, and Open Ethereum was it's not maintained anymore as of last year. So the problem is a lot worse now with execution clients. Consensus clients, it's okay because there's a lot of effort put behind ensuring diversity, but it's still not that great. The most used client is Prism. My case is that there is a similar problem in wallets as well. A vast majority of extension wallets, or rather all extension wallets, they use the same set of JavaScript dependencies, and that's Ethers.js, Web3.js, and so on. It's good because it makes development easy, but you also repeat the same mistakes over and over again. So what is it that we do? We implemented the core functionality of the wallet from scratch, completely free of Web3.js and Ethers.js. These are great libraries, by the way. But we didn't want to, or rather it is more of a security principle not to rely on third-party NPM packages when you don't have to. To my knowledge, that makes us probably the only open source C++ client, Web3 client, that's also actively maintained. You can say Open Ethereum is another one, but it's not maintained anymore. And it sits right inside the browser's core. So it's deeply integrated into our stack. It's cross-platform, so if you can compile Brave, so it could be your Raspberry Pi or your Mac OS, anything, Windows, you would have access to the client. So we do not rely on architecture or platform-specific features. And finally, it is lighter on CPU and memory footprint compared to an extension wallet. If you know how that works, they use an extra browser process to run all the time. OK, I want to talk about permissions, because this is one area where I think we do something cool, and I want to talk about it. So in your regular browsing experience, just open Google Maps. It's going to ask you for location permission. You go to a travel website, it's going to ask you for notifications. And on Zoom, it's going to open your camera. And the browser has certain security features that prevents these websites from accessing your camera if you have not granted the permission. That's great. So we used it. So just like your location, camera, microphone, some websites even access motion sensors. I don't know why, but you have these a lot of these permissions, notifications. We created one for Ethereum. So if you block access to Ethereum for a particular site, it cannot do anything with window.ethereum. And this is enforced at the browser level, not by JavaScript, which is good. Just like any other permissions, we can also make it temporal. So when you connect a dApp, grant permission to access window.ethereum, interact with the wallet, you can also say, clear this permission in once I close the site, or in 24 hours, and so on. This is great because dApps can still sometimes access, like know your address and stuff like that, maybe create false message signing requests. If you don't want them to do that once you have closed the website, you have a way. And this is my personal favorite. There's permission isolation. Imagine you're on Uniswap, and you're connected to Optimism. And on another dApp, let's say Curve or 1inch, you can connect to another network. They are talking to the same wallet, but they're using different networks. It's not that fancy, but it's a useful feature. You don't want to switch network on one dApp and have it reflected on another dApp. And this isolation is guaranteed by the browser. Again, not through, not in a phony way through JavaScript. What about untrusted content? So pretty much anything coming from the outside world. So that would include images, HTML content, XML, responses from third-party APIs. They are all untrusted content. They can, we don't want them to impact your wallet or crash your browser, and so on. So we have a solution for that at Brave. So what we do at Brave is we follow something that we call a rule of two. Rule of two says that it's just a security hygiene. That's it. The rule says you can pick no more than two of three things. One, untrustworthy input. So that would be the NFT image that you are rendering on your screen, or third-party API responses. Two, unsafe language implementation. So anything you write in C++ or C, that's considered unsafe. So what's safe? Safe. Rust is safe. So whenever we talk to APIs, it can even be RPC nodes, a Geth node. We make sure that the response is sanitized in Rust, and it's something that is valid JSON. Like most of these JSON responses are not really valid because numbers in most blockchains are pretty large, and they are not standard numbers in JavaScript. And third, we don't want to do things that require high privilege. I mean, you can do that, but not all of them together. High privilege is something when you do it in the main browser process. So we don't want some piece of cryptography to crash your browser, for example. And if you have a coincidence of these three evil things, doom. We don't do this. So that's our rule of two. It's a general rule for that you can also apply to other softwares. We have another interesting piece of technology known as untrusted frames. So whenever we show an NFT, for example, this NFT. NFTs could have any media content. It could be arbitrary. We make sure that it's rendered within what we call an untrusted frame. It's basically a tiny sandbox that limits the kind of things that can be done within that frame. So for security purpose, you can have a malicious SVG that's doing something. We also do that for connecting with hardware wallets. So hardware wallets actually use vendor-specific communication libraries, so maybe a JavaScript NPM package, and they can be compromised. We don't want Brave users worldwide to be impacted by a vendor library of a hardware wallet. So what do we do? What we do is we make sure that the communication with the device, with the hardware wallet, happens within an untrusted frame. So this library that's normally used to talk over USB or Bluetooth, we make sure that it has the protections of this untrusted frame. Some other features, some of my little personal favorites, things outside wallets, but you would find them sprinkled around in the user experience of browsing. The reason I want to talk about it is that stuff like this, like when you visit an IPFS URL, for users, it feels as if it's a regular website, apart from some fancy logos, but it feels native. You don't have to know that it's a Web3 website, IPFS hosted. Also works with IPNS names. Did you know that you could run an IPFS node in Brave? So you could let Brave spin up and manage a local IPFS node. And then you can do some interesting stuff with it, like importing files, pinning content to your local node, pinning your NFTs, so on. And it's not that, I don't know if you can see the numbers, but it's not that heavy. It's pretty light. For those who have used Brave a lot, you may have seen those purple IPFS buttons in the URLs. And what this is about is, if there is an IPFS hosted version available for this URL, what we do is we show this button, and then you can view it in a gateway. But the cool thing is, if you have a local node running, it's going to open it in your local host. So this image, the one at the bottom, that's being served through the local host. That's the IPFS, the Filecoin website. Pretty cool. So I want to wrap up here and talk a little bit about what we are doing and why we are doing and how we are doing. So a browser is something that every internet user has. It's the most sophisticated piece of software that you have on your device right now. You use it every day. And we have good distribution. We reach a lot of users. And we want all of them, each of them, to have the option to use crypto in a native way. Maybe you don't even know that you're using Web3 things. That's how we want to build our product. We have an expertise building browsers, so we want to leverage that. We want to leverage our browser to offer experiences that feel a bit more native and don't get in the way. And a lot of those things may not be possible with extension wallets. And finally, every product that we build, we try to add some character and make it maximally private, even if it means it's going to hamstring you. And we want it to reflect the wider culture we have at Brave. And one of them is open source. By the way, most or a lot of crypto wallets out there are not open source. And I'm not just talking about wallets that do not use permissive licenses, but they just don't have a publicly viewable source code. Robinhood wallet. So yeah, that's it. Thank you all for listening, and yeah, see you around.